Good morning, students. Hello.
Good morning, sir.
Good
Good
morning.
morning.
Now we'll begin with chemistry and its compounds. A new topic. Chemistry and its compounds. Carbon and its compound, not chemistry. Carbon and its compounds, right? Now, carbon, its atomic number is 6. Its atomic number is 6, right? Atomic number of a carbon is 6. So electronic configuration, it is 2,4. What is electronic configuration? 2,4. Is it voice is audible?
Yes, sir.
Okay. So its electronic configuration is 2,4. This indicates that carbon consists of 4 electrons in the outermost shell. In the outermost shell. How many electrons? 4 electrons. Right. Therefore, valency of carbon it is 4. Valency of carbon is 4 since it consists of 4 electrons in the outermost cell. Now,
Sir, you haven't shared the screen.
1 minute. 1 minute. 1 minute. Sir. शेयर स्क्रीन शेयर करना है
तो कोई आया
स्क्रीन
इसमें
हाँ वो बोल रहे थे स्क्रीन शेयर करो
इससे होता है ना शेयर स्क्रीन
जूम पे लिए गए नहीं तो कट हो जाएगा 40 मिनट के बाद
नहीं नहीं सर का काम ए
okay. So valency of carbon is how much? Now screen is shared. Is it visible?
Yes, sir.
Okay, okay. So valency of carbon is 4. It could not gain 4 electrons. Could not gain 4 electrons. Right. Since 6 proton will not be able to hold tail electrons. Correct or not? Carbon ka atomic number is 6. So carbon consists of 6 proton. So additional 4 electron, total 10 electron. 6 protons are there. That is 6 protons means 6 positive charges. Right or not? So is never ever equal to 10 electrons. Why? Because 6 positive charges, they cannot be neutralized by 10 negative charges. So 4 negative charges will be extra. Similarly, carbon can't lose 4 electrons. 4 electrons since it required large amount of energy. Large energy to remove these 4 electrons, right? As a result, carbon prefers to share 4 electrons with other atom to complete its octet. 4 electrons with other atom to complete its octet. Complete its octet. Octet. ठीक है? कोई डाउट है? Is there any doubt? Students?
No, sir.
Okay. Next one is catenation. Next one is catenation. What is catenation? Tendency of an element to form a bond with another same element, forming a long chain or branch chain or ring chain, that is called catenation. Okay. For example, carbon, it has a tendency to form a bond with another carbon, and thus it forms a long chain. It forms a long chain. This is nothing but n-hexane. n-hexane, right? Normal hexane बोलते हैं. Or branch chain, that is CH3, C, CH3, CH3, CH2, CH3. This is a first, actually this is nomenclature we'll see very soon. This is a first carbon, second carbon, third and fourth. So 2,2 dimethyl butane, 2,2 dimethyl butane, right? So this is the branch chain. Okay. Now a ring chain means what? You know, one carbon joined to another carbon, then that joined to next carbon, that joined to next carbon, and the last carbon joined to first carbon. So this is called cyclobutane. Cyclobutane. So this tendency of a carbon to form a bond with another same carbon, forming a long chain or branch chain or cyclic chain, that is called catenation. Catenation. Okay. So tendency of a carbon, tendency of a carbon to form long chain or branch chain or cyclic chain is called catenation. What it is? Catenation. कोई doubt है? Now, है ना? Allotropes of carbon. Next part is allotropes of carbon. What is mean by allotropes? Allotropes. Elements having same chemical properties but different physical properties, they are called allotropes. And the phenomenon shown by them is allotropy. Elements having similar chemical properties but different physical properties are called allotropes. Elements having same chemical properties but different physical properties, are called allotropes. And the phenomenon shown by them is called an allotropy. It's called an allotropy. Okay. It's called an allotropy. Okay.
The story of Kantara.
reminds us that true power lives on. Team Country Life joins Team Kantara.
Just minute,
celebrating our
students.
roots and traditions.
हॅलो हॅलो काय म्हणते? ओके. संदीप मेडिकल कसे आले? हा बघ, तिथे ना आंब्याचं झाड आहे बघा एक. आतमध्ये या, ते पांढरी बिल्डिंग दिसली का तुम्हाला एक? असं ग्रे कलरचे पत्र्याचे शेड आहेत ना, त्याच्या पुढची बिल्डिंग. नंतर येलो कलरची बिल्डिंग आहे, अशी दोन व्हाईट गेट आहेत. हा हा, मग त्या दुसऱ्या गेटनी वरती जावा, एक नंबर फ्लॅटला. हा हा, बरोबर. दोन लोखंडाचे गेट आहेत बघा साहेब. तर उजव्या साईडच्या गेटनी वरती जावा. डाव्या साईडचं बंद असते. उघडलं का गेट? स्टुडंट प्लीज जस्ट मिनिट, सम पार्सल इज देअर. So, what are allotropes? Elements having same chemical properties but different physical properties. They are called allotropes, and the phenomenon shown by them is called allotrope. भेटलं भेटलं ना सर? बरं बरं, जमा करा. हा, ओके. So, elements having same chemical properties but different physical properties, they are called allotropes, and the phenomenon shown by them is called allotrope. What it is? Allotrope, right? So, carbon, it exists into three different allotropes. Three different allotropes. Okay. And we'll see this in the form of a distinguish. That is, here is a, we can say graphite. The next one is diamond. Mm, We'll do like this. First one is diamond. Diamond. Second one is graphite. And third one is fullerene. Fullerene, right? So, now diamond, it has a three-dimensional network-like structure. That is, this is a one of the carbon, this is another carbon. So in diamond, every carbon is attached to four other carbon. Is attached to four other carbon. Okay. Four other carbon. Okay. So it is having three-dimensional network-like structure. Three-dimensional network-like structure. Or tetrahedral structure. Tetrahedral structure, right? Then graphite, graphite, it has a layered structure. So this is what a honeycomb hue. Okay, honeycomb hue. So they have a same structure like honeycomb hue. Okay. So they are having similar structure like honeycomb hue, and these layers of a graphite, they are held together by weak van der Waals forces, and that's what it is. Flaky and slippery in nature. Flaky and slippery in nature. If you find in this case, that is every carbon is attached to three other carbon. For example, this central carbon, it is attached to three other carbon. Right. Now it say no, sir. Terminal carbon is not attached to any carbon. But terminal carbon is also attached to next three carbons since the structure is three-dimensional. Structure is three-dimensional. Okay. So graphite, it is a trigonal planar structure. Trigonal planar structure. Graphite, it has a trigonal planar structure. Then fullerene, uh, it has a football-like structure. In brief, that is spherical structure, in which there are certain hexagon and certain pentagons. Now, hexagon may attach to another hexagon or to another pentagon, but pentagon is attached to only hexagon. Okay. Like this. So this is pentagon, this is pentagon, right? This is pentagon. Okay, pentagon. So pentagon is attached to only hexagon, but not to other, uh, not to other. Pentagon is attached to hexagon, but not to other. We can say pentagon, right? You can say other pentagon. Okay. So this sort of spherical structure that is nothing but spherical structure. In this case also, every carbon is attached to three other carbons. How many? Three other carbons. The next point is an electrical conductivity. Electrical conductivity. So generally, only graphite it is electrical conductor. Okay, since it consists of alternate single and double bonds, that is benzene ring-like structure, and that's why it is electrical conductor. Okay. Then, thermal conductivity. Thermal conductivity. Diamond, it has a high thermal conductivity. Graphite, low. And fullerene, again high. Again high. Now, what are the uses? Diamond, it is used in jewelry for decoration purpose. Then graphite, it acts as a solid lubricants, and conductor of electricity. Although graphite is non-metal, it acts as a good conductor of electricity. Then, fullerene, it is used to control AIDS, that is acquired immunodeficiency syndrome. Acquired immunodeficiency syndrome. Okay. Is there any doubt? Now, carbon is tetravalent. Already we've seen, but still, carbon is tetravalent. Okay. Why? Atomic number of carbon is 6. Then its electronic configuration is 2, 4. So it forms or it shares its 4 electron with other atom to complete the octet, and therefore carbon is tetravalent. Carbon is tetravalent. Carbon is tetravalent. Is there any doubt? All of you understood allotropes and all?
Yes, sir.
Okay. Okay. Then next property of a carbon is chemical reactions. Chemical reactions of carbon. Okay. What is next property? Chemical reactions of carbon or chemical properties of carbon. Chemical properties of carbon. Chemical properties of carbon. Before studying chemical properties, we'll study types of bond in carbon. Types of bond. Generally, carbon forms a covalent bond. Covalent bond. What is covalent bond? The bond which is formed by equal sharing of electron, that is called what? Covalent bond. For example, if you want to go for a party, Ram contributes 500 rupees, Sham contributes 500 rupees. So contribution is equal. Contribution is equal, right or not? And this equal contribution, that is called what? Mutual contribution. Okay, mutual contribution. That is called what? Mutual contribution. Equal contribution is known as what? Mutual contribution. Okay. So the bond which is formed by equal sharing of electrons. That is, one electron is given by first carbon, one electron is given by second carbon, and thus it forms a covalent bond. The bond which is formed by equal sharing of electrons, okay, is called covalent bond. That is called what? Covalent bond. The bond which is formed by equal sharing of electron, that is called what? Covalent bond. Right? So carbon generally forms a covalent bond. Generally forms a covalent type of bond. Of course, there are further two types of covalent bond: polar covalent bond and second, non-polar covalent bond. Polar covalent bond and second, non-polar covalent bond. Right? Polar covalent bond and non-polar covalent bond. So what is first? Polar covalent bond. Now bond which involve charge separation. Okay. For example, CH3Cl. So chlorine pulls electrons of carbon towards itself. As a result, chlorine acquires negative charge, carbon acquires positive charge. So this separation of charges, that is called polarization. And water bond form, that is called what? Polar covalent bond. Okay. The bond which involves separation of charges, separation of charges, separation of charges is called polar covalent bond. Is called what? Polar covalent bond. What it is called? Polar covalent bond. And the bond which do not involve separation of charges, that is called what? Non-polar covalent bond. Best example is CH3CH. First carbon gives one electron, second carbon gives one electron. After sharing of electron, the charge is not pulled by any one of the atom, and that's why it is called non-polar covalent bond. That is called what? Non-polar covalent bond. It is called non-polar covalent bond, right? So the bond which do not involve separation of charges is called non-polar covalent bond. Non-polar covalent bond. Is there any doubt to anybody? The next one is chemical reactions. Chemical reactions of carbon. Now, carbon, it undergoes a reaction like first combustion. Combustion means burning. Combustion, nothing but burning. Burning. For example, methane. This is what? Methane, CH4, combine with oxygen, forming CO2 and water. CO2 and water. So whatever may be the number of carbon, that much amount of CO2 is formed. Whatever may be the number of hydrogen divided by 2, will get twice H2. So whatever may be the carbon atoms are there, that much amount of CO2 is formed. And then N plus 1 amount of CO2 is formed. How much? N plus 1 amount of CO2 is formed. So, sorry, whatever may be the number of carbon atoms, that much amount of CO2 is formed. And N plus 1 amount of water is formed. So 1 moles of a carbon is there. So 1 plus 1, 2 CO2 is formed, right? Along with that, some heat energy is given out. Heat and some amount of light energy is also given out. Okay, heat, light, these are the forms of energy. So what is combustion? Combustion involves burning of carbon in presence of excess of oxygen. Combustion involves burning of carbon in presence of an excess of oxygen. Excess of oxygen. Then second one is oxidation. What is second? Oxidation. Now, what is oxidation? Oxidation means controlled combustion. Oxidation means controlled combustion or burn. Controlled combustion or burning. Oxidation means controlled combustion or burning. For example, ethanol, CH3, CH2OH. This is what? Ethanol. Whenever subjected for alkaline KMnO4 in presence of acidified potassium dichromate plus heat, what you'll get? You'll get ethanoic acid. Ethanoic acid. What you'll get? Ethanoic acid. The next reaction is called substitution reaction. Substitution reaction. Now, what is substitution reaction? Now, earlier, little bit of late arrival, Amritanshu sir took your lecture, right? So now, once I came, Amritanshu sir was replaced by me. So this replacement of one atom by another atom, ATO atom, okay, that's called what? Substitution reaction. Replacement of one atom by another atom, that is called what? Substitution reaction. So replacement of one atom by another atom is called substitution reaction, right? So CH4, this is methane plus chlorine in presence of UV light. What is meant by UV? Students?
Ultraviolet.
Correct, very good. Ultraviolet light or diffuse sunlight. Diffuse sunlight means anybody knows? What is meant by diffuse sunlight? You know it or you don't know it? Students, diffuse means less intensity. Diffuse means less intensity. So UV light or diffuse sunlight. Less intensity sunlight. That is before 9 a.m. or after 5 p.m. Before 9 a.m. or after 5 p.m. The next addition reaction. Fourth one is addition reaction. Right. Now CH2, double bond CH2 plus H2. What is this? Ethene. Okay. One hydrogen atom is added to first carbon. Another hydrogen atom is added to second carbon. Double bond is converted to single bond. That is ethane. And this reaction that is also called hydrogenation. What it is called? Hydrogenation. Hydrogen means hydrogen. Ation means addition. So it involves addition of hydrogen. It involves addition of hydrogen. So ethene is unsaturated, and ethane is saturated. So degree of unsaturation goes on decreasing, and degree of saturation goes on increasing. Degree of unsaturation goes on decreasing, and degree of saturation goes on increasing. Is there any doubt? Is there any doubt? Is there any doubt?
No, sir. No, sir.
The next point is ethanol. Is one of the carbon compound, right? Ethanol is what? C2H5OH. Ethanol is what? C2H5OH, right? Now, next point is hydrocarbons. Next point is hydrocarbons. Now, what are hydrocarbons? Hydrocarbons are the element. They consist of hydrogen and carbon, right? Next point from this hydrocarbons. Hydrocarbons. Now, what are hydrocarbons? Compound containing carbon and hydrogen as the element only. That is called hydrocarbons. Compound containing hydrogen and carbon as the elements only are called hydrocarbons. Right. So compounds containing hydrogen and carbon as the elements only, they are called what? Hydrocarbons. Now, hydrocarbons, they are further subdivided into three parts. That is alkanes, second one, alkenes, and third one, alkynes. Third one is alkynes. Now, alkanes, their general formula CnH2n plus 2. Alkenes, their general formula CnH2n. Alkynes, their general formula CnH2n minus 2. Right? Now, alkanes, they have general formula CnH2n plus 2. Right? Means what? If we substitute n is equal to 1, what do you get? C1 H, 2 ones are 2 plus 2. So CH4, nothing but methane. Nothing but what? Methane. Then 2, n is equal to 2. C2, H, 2 twos are 4 plus 2, 6. H6, nothing but ethane. If you substitute n is equal to 3, what will get? C3. H, 2 threes are 6 plus 2, 8. Nothing but propane. If we substitute n is equal to 4, what will get? C4. H2 fours are 8 plus 2, 10. C4H10, nothing but butane. If we substitute n is equal to 5, what will get? C5. H2 fives are 10 plus 2, 12. Nothing but pentane. If you substitute n is equal to 6, C6H14, that is hexane. If we substitute n is equal to 7, C7, H16, nothing but heptane. N is equal to 8, C8, 2 8s are 16 plus 2, 18. So C8H18, nothing but octane. Then 9, C9H20, nothing but nonane. Then 10, C10, H22, decane, etc. etc. Now, clamping cannot be done by a single hand. So just like that, there is no formation of a carbon-carbon double or triple bond takes place whenever a single carbon is involved. So whenever n is equal to 2, what will get? C2, H, 2 twos are 4. So C2H4, nothing but ethene. Then C3H6, nothing but propene. When n is equal to 4, what will get? C4H8, nothing but butane. N is equal to 5, pentane, that is C5H10, nothing but pentane. N is equal to 6, C6H2 6 are 12, C6H12, nothing but hexane. Then n is equal to 7, C7, H2 sevens are 14. So C7, H14, nothing but heptane. N is equal to 8, what will get? C8, H2, 2 8s are 16. So octane. N is equal to 9, C9, H18. Nothing but nonene. Then C10, H20, decane, etc. Then alkyne series. What is general formula? CnH2n minus 2. So whenever n is equal to 2, what will get? C2. H 2 2s are 4 minus 2. So C2H2, nothing but ethyne. Nothing but ethyne. Whenever n is equal to 3, what will get? C3, H2 3s are 6. 6 minus 2, 4. C3H4, nothing but propine. Nothing but propine. Then, n is equal to 4, we'll get C4. H2 4s are 8 minus 2. So C2, C4, H6, nothing but butane, right? Whenever n is equal to 5, what will get? C5, H, two fives are 10 minus 2. So C5H8, nothing but pentine. Nothing but pentine. N is equal to 6, what will get? C6, H2 6 are 12 minus 2. So C6H10, nothing but hexine. N is equal to 7. What will get? C7. H2 sevens are 14 minus 2. So C7H12, nothing but heptine. The next CH16 minus 2, 14. So octine. N is equal to 9. What will get? C9. H2 nines are 18 minus 2, 16. So C9H16, nothing but nonine. Similarly, C10, H 10 twos are 20 minus 2, 18, nothing but dekyne. Nothing but what? Dekyne. Is there any doubt to anybody? Is there any doubt to anybody? Students?
No.
Okay, okay. The next one is homologous series. Homologous series. What is homologous series? If we consider, for example, hexane and heptane, okay, hexane and heptane. Heptane, its formula is C7H60. Then hexane, its formula is C6H14. If we subtract hexane from heptane, what is remaining? CH2. CH2 is called methylene. Methylene. Right. So what is homologous series? The series of element having same general formula, okay, same functional group, in which two successive members differ from one another by constant difference of CH2, that is methylene group, okay, that is known as homologous series. Carbon, its atomic number is 12. Carbon, its atomic number is 12. So 12 into 1 plus hydrogen 1 into 2. So that is equal to 12 plus 2, nothing but 14. Nothing but 14. So what is homologous series? A series of elements in which two successive members differ from one another by constant difference of CH2. That is by 14 units. By 14 units. That is called what? Homologous series. What are the characteristics of homologous series? If you see properly, for example, alkane, any member of alkane like nonane, octane, heptane, etc. They show same general formula. What is that general formula? They show same general formula. Okay. Characteristics of homologous series. So what is first? They have same general formula. Same general formula. Second, they have same functional group. Same functional group. That is carbon-carbon single bond, alkanes. Alkanes, okay. Now, every member of two successive member of the series differ from one another by constant difference of CH2, nothing but methylene, nothing but methylene. That is by 14 units, 14 units, right? Now, you know, they show similar chemical properties. Similar chemical properties. Means what? If methane undergo oxidation, then ethane also show oxidation, propane also show oxidation. Similarly, non and decane, they also undergo oxidation. So they show similar chemical properties. Okay. They show regular gradation in physical properties. Regular gradation in physical properties. Regular gradation in physical properties. Okay. Is there any doubt to anybody about this? Yes. Is there any doubt?
No.
So what is homologous series? Series of element in which they are having same general formula, same functional group, and two successive members differs from one another by constant difference of CH2. That is methylene group. That is called what? Homologous series. That is called what? Homologous series. That is called homologous series. Is there any doubt? Then, well, this is the end of, we can say, chemistry of carbon compounds. That is carbon and its compound. Then we'll begin with metals and non-metals. Next topic. That is next chapter, you can say. Metals and non-metals. Now, what is metal? Gold, platinum, silver, they are metals. Why they are called metals? Metals are the elements. They are having a tendency, for example, magnesium, to lose electron and gets converted to positively charged cation. Gets converted to positively charged cation. Okay. Metals are the elements. They are having a tendency to lose electron and gets converted to positively charged cation. Gets converted to positively charged cation. Okay, this is what? Magnesium cation. This is what? Magnesium metal. Magnesium metal, right? So, magnesium metal undergo loss of electron forming Mg2 plus ion, that is magnesium cation, right? So, metals are the elements which has a tendency to lose one or more electrons and gets converted to their positively charged cation. Gets converted to their positively charged cation. They're called what? Metals. What they're called? Metals. Is there any doubt? So, there are several examples of metal, like sodium is there, potassium is there, lithium is there. Okay. rubidium, cesium, francium, etc. Similarly, beryllium, magnesium, calcium, strontium, barium, radium, etc. So all these are what? Metals. Similarly, transition metal or D block metals includes iron, Fe, copper, Cu, then silver, Az, gold, Au, then platinum, Pt, then palladium, Pd. Okay. Is there any doubt? Is there any doubt? All of you understood definition of metal?
Yes, sir.
Okay. Okay. Then, you know, gold denoted by symbol Au, gold. Then silver, Az, and platinum, Pt. They are called noble metals. Noble metals. Since they are less reactive. Since they are less reactive. They are less reactive. These elements, they are less reactive. Is there any doubt? Is there any doubt? Then, what is next? Non-metal. Non-metal. Now, what is non-metal? Non-metals are the element which has a tendency to gain one or more electrons and gets converted to negatively charged anion. Okay, for example, chlorine has a tendency to accept electron and gets converted to negatively charged anion, gets converted to negatively charged anion. So this is what chlorine molecule, and this is chloride ion. So non-metal is an element which has a tendency to gain one or more electrons and gets converted to negatively charged anion. Okay, and that's called what? Non-metal. Is there any doubt? So, there are several non-metals: carbon, nitrogen, oxygen, fluorine. So all these are non-metals. Generally, non-metals, they are solids or gases, except bromine, which is liquid. Except bromine, which is liquid. Which is liquid, right? Now, we'll study a distinguish between metals and non-metals. Distinguish between metals and non-metals. Okay, so we'll write here metals, here non-metals. Now, what are metals? Metals are the element which has a tendency to lose one or more electrons and gets converted to positively charged cation. So they are having a tendency to lose electrons, to lose electrons and forms cation. Non-metals have a tendency to gain electrons and forms anion, right? Second, metal, when are cut, they show shiny surface, and that property is called luster. So metals are lustrous in nature. That is, they are shiny in appearance. Now, why metals they are lecturers? Metals are lecturers. It's because of what? Whenever light falls on the surface of metal, whatever free electrons present in that metal that takes or gains the energy, they undergo excited state, right? And while coming to the ground state, they lose energy in the form of a light. And that's why they show shiny surface. Gold, shiny. Okay. Then silver, shiny in nature, right? Now, non-metals, they are non-lecherous. Non-lecherous. That is, they do not show shiny surface. The next, metals, whenever hammered, they gets converted into thin flat sheets, and that is called malleability. Malleability. Malleability means whenever metals they are hammered, they gets converted into thin flat sheets, and that property is called that's why metals they are called malleable, and tendency or phenomenon shown by them is called malleability. Phenomenon shown by them is called malleability. Okay. Phenomenon shown by them is called malleability. Is there any doubt? Now, generally, non-metals, they are non-malleable. Non-malleable. Okay. That is, on hammering, they don't get converted into thin flat sheet. Instead of that, they undergo breaking. The next, ductility. Next point is ductility. Metals, they are generally ductile in nature. That is, whenever forced, they are drawn out in the form of a thin wire. And this tendency or phenomenon is known as what? Ductility. Non-metals, they are non-ductile. Non-ductile. Now, you might have observed in earlier days, the bell in the school was made up of a iron. It is a circular coil. It is a circular coil, right? So, circular coil made up of what? Iron. Made up of what? Iron, right? And it is hammered. So, it produces a sound, ringing sound. And that tendency is called what? Sonority. So, metals are sonorous. Sonorous. That is, they produces ringing sound. What's about non-metals? They are non-sonorous. Non-sonorous. The next point. Metals are good conductor of heat and electricity. Good. Generally, conductors of heat and electricity. Okay. Then, generally, non-metals, this is generally, not 100% applicable. Generally, non-metals are bad conductors, not bus conductor. Bad conductors of heat and electricity. Non-metals, they are generally bad conductors of what? Heat and electricity. Is there any doubt? Now, next point. Generally, metals, they are solid at room temperature. They are generally solids at room temperature, except mercury, which is liquid. Except mercury, which is liquid. Generally, non-metals, they are solids or gases. Solids or gases, except bromine, which is liquid. Which is liquid. Is there any doubt to anybody? Is there any doubt to anybody? Pardon? डाउट है क्या कुछ?
No.
No doubt. Okay. The next, you know, next point is reactions of metals and non-metals. What is next point? Reactions of metals and non-metals. Reactions of metals and non-metals. Reactions of metals and non-metals. Now, metals as well as non-metal, okay, they are having a tendency to react with water. Then no metals they react with acid. Non-metals they react with bases. Likewise, they are having different tendencies. They are having different tendencies. So we'll study chemical reactions or chemical properties of metals and non-metals. Chemical properties of metals and non-metals. Right. Chemical properties of metals and non-metals. Generally, metals they undergo oxidation, that is reaction with oxygen. We can say reactions of metals. Okay. First, oxidation. Oxidation involves addition of oxygen. Oxidation involves addition of oxygen. Addition of oxygen. For example, one minute. For example, sodium combined with oxygen plus O2 gives twice Na2, sodium oxide. Similarly, 4K plus O2 gives twice K2, potassium oxide. Then lithium combined with oxygen, forming lithium oxide. Similarly, calcium combined with oxygen will get calcium oxide. What do you get? Calcium oxide. Okay. Similarly, magnesium combined with oxygen will get magnesium oxide. Will get magnesium oxide. Then aluminium combined with oxygen will get Al2O3, aluminum oxide. Generally, oxides of non-metal, they are basic. They are basic in nature. Only aluminum oxide is amphoteric. 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 Ampho means both. That is, it shows properties of both acids as well as bases. So, twice copper plus oxygen gives copper oxide. Here's copper oxide, right? Then, already I told you, aluminum oxide is amphoteric in nature. Similar to aluminum oxide, zinc, whenever combined with oxygen, okay, it also forms amphoteric oxide. Amphoteric oxide. It also forms what? Amphoteric oxide, right? That is, it behaves as acid as well as base. Then metal combined with water. Uh, Second, that is reaction with water. Reaction with water. With water. So, sodium combined with water forming twice NaOH plus H2 gas is given out. Similarly, calcium combined with 2 molecules of water forming CaOH twice plus H2 gas is given out. Now, magnesium do not react with cold water. Magnesium react with hot water and forms magnesium hydroxide and H2. Magnesium plus 2HOH. Of course, only hot water. So we'll get MgOH twice plus H2. Right? Then aluminum combines with water twice Al plus 3HOH. What will we get? We'll get Al2O3, aluminum oxide, plus thrice H2. Thrice H2. Is there any doubt? Metal, such as a lead, copper, silver, gold, they do not react with water at all. Okay. So, decreasing order of reactivity of metal, decreasing order of reactivity of metal with water, it is what? Magnesium react on hot condition, then aluminum, then zinc, and then iron. Iron. The reaction of metal with acids. Next, third one is with acids, reaction with acids. Metal combine with acid forming salt and water. Metal plus acid forming salt plus water. Salt plus water. For example, potassium combine with aqueous hydrochloric acid forming what? Twice KCl, potassium chloride as a salt, hydrogen is given out. Similarly, twice N combined with 2 molecules of HCl forming twice NaCl plus H2 gas. Similarly, calcium combined with forming CaCl2 plus H2. Then magnesium combined with HCl forming MgCl2 plus H2 gas is given out, right? Copper, silver, mercury do not react with dilute acid. Copper, silver, and mercury, okay, they do not show reaction with dilute acid. Dilute acid, okay. The next, aluminum reacts slowly with dilute HCl and then fast. The next, Aquaresia. What is aquaresia? Aquaresia means Latin word royal water. In Latin, royal water. Royal water. Okay. So it is freshly prepared mixture of concentrated hydrochloric acid, okay, with nitric acid in the proportion 3:1. In the proportion 3:1. That is, it is a mixture of HCl and nitric acid in the proportion of 3:1. All goldsmithers, they are using this for bringing shiny nature to the ornaments, to the ornaments. Okay. Is there any doubt? Students, is there any doubt?
No, sir.
Okay. Now, reaction of metal with solution of other metal salt. Okay. Reaction of metal. Next part is reactions of metals with salts of salts of other metals, salts of other metals, right? For example, Fe combined with copper sulfate, it displaces copper from its salt solution and it forms FeSO4 ferrous sulfide and copper becomes a free. Copper becomes a free, right? And this is called displacement reaction. Which reaction? Displacement reaction. Similarly, ZnS combined with FeSO4 aqueous gives ZnSO4 aqueous. AQ means aqueous plus Fe solid. Fe solid. Is there any doubt to anybody? Is there any doubt? Students? The next, reactions of nonmetals. Reactions of nonmetals. Next part is reactions of nonmetals. Right. Reactions of nonmetals. Reactions of nonmetals. Okay. Next point is what? Reactions of nonmetals. Okay. Now, metal like reaction of non-metal. First, oxidation. Carbon combined with oxygen. Carbon is non-metal, forming what? CO2. Similarly, nitrogen combined with oxygen, forming what? N2O3, right? That is nitrous oxide. Then, fluorine combined with oxygen, forming O2F2. Okay. So this is what oxidation. Then reaction with water. Reaction with water. Carbon combined with water, forming what? Carbon monoxide gas plus hydrogen gas, right? Generally, Oxides of non-metal, they are acidic in nature. Oxides of non-metal, they are acidic in nature. Is there any doubt? Similarly, fluorine, 1 minute, will not consider fluorine. I will consider chlorine. Chlorine combined with HOH, right? What will get? Will get HOCl plus HCl. HCl 1 molecule, HOCl 1 molecule, right? Plus water again. If we add 1 molecule of water, that is also enough. Best way, we'll add 1 molecule of water so that excess will not remain. So you'll get HOCl and HCl. Okay, HOCl, it is called hypochlorous acid. Hypochlorous acid. Hypochlorous acid. Okay. Is there any doubt to anybody? Is there any doubt?
आपने खाया नहीं क्या अभी तक?
बेटा फास्ट है आज, आप खाओ और पानी लेके आओ. Is there any doubt to anybody?
No.
Okay. Now, physical properties of non-metals, they think physical properties of metals and non-metals. Metals, they are generally having high melting point and boiling point. Non-metals, they have low melting point and boiling point. Generally, metals are good conductor of heat and electricity. Non-metals, they are bad conductor of heat and electricity. Of course, graphite is a good conductor. Okay. Then, next part is refining of metals. Now, what is refining of metal? Refining means purification. Refining of metals means removal of impurities. Removal of impurities. Impurities. What is impurity? Impurity. Impurity is a substance which, when added in a trace amount, changes the properties of main substance. That is called what? An impurity. What is impurity? Impurity is a substance present in a trace amount. Okay. Changes the properties of main substance. That is called what? An impurity. That is called what? An impurity. Okay. For example, whenever guests arrives in your house, your mother used to prepare either tea, coffee, or lemon juice. Now consider it's a summer season and she prepared lemon juice. If we add 2 drops of a bitter gourd juice in it, what could be the taste? Yes, student. If we add 2 drops of bitter gourd juice in a lemon juice, what is the taste of that lemon juice? Yes, students.
Bitter.
Bitter, very good, very good. So it's a bitter, correct or not? So 2 drops of lemon juice has a capacity to change the properties of 200 ml of lemon juice. How many ml of lemon juice? 200 ml of lemon juice. And this indicates that impurity is a substance that is present in a trace amount or small amount, but changes the properties of main substance. Got it? The next part. Metals, they undergo corrosion. Now, what is corrosion? Metals combine with oxygen in presence of water and forming its oxide, and that is called what? Corrosion. Okay. Metals, they combine with oxygen in presence of water. Okay, only oxygen. When comes in contact with metal, it will not form its oxide, right? Or it will not undergo corrosion. It will form oxide, but it will not undergo corrosion. So it forms metal oxide. This combined effect of oxygen and water to, to convert metal into metal oxide, the process is called what? Corrosion. The process is called what? Corrosion. So what is corrosion? Corrosion is a process. Corrosion is an electrochemical or chemical process of decay or destruction of metal due to combined effect of oxygen and air. Oxygen and air. So corrosion is chemical or electrochemical decay or destruction of metal due to combined effect of oxygen, air, okay, owing to surrounding medium. Owing to, that is air and oxygen present in surrounding medium. Surrounding medium. Owing to surrounding medium. Now, how to prevent corrosion? Prevention of corrosion. First, by painting, by applying paint on the surface of metal. Second, by oiling, by oiling. By greasing, by applying grease on metal surface. Next, by galvanizing. Galvanizing. What is galvanization? Coating of metal, base metal with zinc. Coating of metal with zinc. Coating of metal with zinc. With zinc. That is called what? Galvanization. Then chrome plating. Chrome plating. Applying chromium. Then anodizing. Anodizing. Or making alloys. Or making alloys. Now, what is alloy? Alloy is a mixture of two or more metals. Okay. Alloy is a mixture of two or more metals. It may be homogeneous or heterogeneous. Okay. Basically, alloy is a mixture of two or more elements, out of which at least one should be metal. At least one should be metal. At least one should be metal. So an alloy is a mixture of two or more elements in which at least one should be metal. Then next part is, there are various alloys like amalgam, alloy. First alloy is amalgam. Amalgam, it is a alloy of mercury and other metal. Other metal. For example, silver amalgam. It is used to fill the cavities in the teeth. Silver amalgam. That is AZHG. It is used to fill cavities in teeth. So filling in teeth. Filling in tin. Then, brass. Next alloy is brass. Brass, it is an alloy of copper and zinc. Brass is alloy of copper and zinc. It is used for electrical fittings. It is used for electrical fittings. Electrical fittings. Then next alloy is bronze. Bronze. Bronze is alloy of copper and tin. And this alloy is used for making statues and medals. Statues and medals. Statues and medals. Then solder. It is an alloy of tin and lead. So it is used for welding electrical wires. Welding electrical wires. Then, stainless steel. Stainless steel. It is an alloy of iron, nickel, and chromium, and it is used for making cooking utensil. Cooking utensils. Utensils. It is used for making cooking utensils. Is there any doubt to anybody? Students, is there any doubt? Students, is there any doubt? Is some doubt is there or not?
No, sir.
Okay, the next one is occurrence of metal. Occurrence of metals. Now, what is meant by occurrence? Occurrence means the source in which metal is found. The source in which metal is found, that is called occurrence of metal. Source in which metal is found, that is called what? Occurrence of metal. Generally, metal occur naturally in the earth crust, okay, in the form of minerals. In the form of minerals. Minerals. So what are minerals? Naturally occurring substances where metal is found. Okay. Naturally occurring substances. Substances where metal is found. They are called what? Minerals. Now, what are ores? Ores are minerals. Ores are minerals from which metal is extracted economically and profitably. Economically and profitable. Economically means with less cost. Profitably, economically and easily, not economic and profitably is one and the same thing. Okay, economically and easily means by putting less effort. Easily, right? Now, extraction of metal from there. So, what is distinguished between ores and minerals? Naturally occurring substances where metal is found, they are called minerals. And what are ores? Ores are minerals from which metal is extracted economically and easily. Economically and easily. They are called what? Ores. So it is said that all ores are minerals. all ores are minerals, but all minerals are not ores. All minerals are not ores. It is said that all ores are minerals, but all minerals are not ores. The next one is extraction of metal from their ores. Extraction of metals from their ores. So it involves 3 steps. Step 1, concentration of ore. Concentration of ore means concentration of ore is done by removal of impurities. By removal of impurities. Removal of impurities. It involves process of removal of impurities. I'll tell in short. Then step 2. Step 2 is what? Conversion of concentrated ore into metal. Conversion of concentrated ore into metal. Conversion of concentrated ore into metal. So what can be done? Twice NaCl on electrolysis. Electrolysis gives twice NaS plus chlorine gas is given out. Chlorine gas is given out. And of course, sodium is collected at cathode and chlorine is evolved at anode. So cathode is an electrode where reduction takes place. Anode is an electrode where oxidation takes place. Oxidation takes place. Right. And this electrolysis method, it is used for extraction of highly reactive metal. Okay. Process of electrolysis. It is used for extraction of highly reactive metals. Highly reactive metals. Highly reactive metals. The next, extraction means separation. Okay. What is extraction? Extraction means separation. The next, extraction of moderately reactive metals. Extraction of moderately reactive metals. Moderately reactive means they are having medium reactivity. They are having medium reactivity. Generally, iron, zinc, and lead, etc., etc. They are moderately reactive metals. Of course, they are extracted by using roasting. By using roasting, and second, calcination. What is roasting? Treating or heating of ore in excess of air, heating or in excess of oxygen, that is called roasting. And what is calcination? Heating of ore in limited amount of oxygen or in absence of oxygen, that is called calcination. Heating of ore in absence of of oxygen or limited oxygen. That is called what? Calcination. Most important. Roasting involves heating of ore in presence of excess of oxygen. Calcination involves heating of ore in limited supply of oxygen. Now, in hotel, when you are going with mom and dad, you are ordering roasted papad. Roasted papad means that is fried directly on the gas. Okay. Then calcination means fried in oil in pan or kadai. Okay. Is there any doubt? Is there any doubt?
No.
Okay, very good. Generally, roasting is applied for sulfide ore, which are sulfide ore. Then calcination, it is applied for calcination. Generally, it is applied for carbonate ores, carbonate or hydroxide ore. Hydroxide ore. Most important, this will be as it is there in 10th standard. As it is there in 10th standard. The next one is thermite reaction. Thermite reaction. What is thermite reaction? Reduction of metal oxide to form a metal by using aluminum as a reducing agent. That is called what? Thermite reaction or thermite process. Reduction of metal oxide to form a metal. Okay. Reduction of metal oxide to metal using aluminum as a reducing agent that is called what? Thermite reaction. Thermite reaction or thermite process. Thermite process. Is there any doubt? So this thermite process is highly exothermic. It is highly exothermic. Highly exothermic. Exo means out. Thermos means heat. So it is a process in which heat is given out. It is given out. Okay. Now, extraction of less reactive metal. Next one is extraction of less reactive metals. Less reactive metal. Mercury is a less reactive metal. So it is obtained from the ore called cinnabar, nothing but mercury sulfide. This is what? Cinnabar, mercuric sulfide combined with 3 oxygen plus heat, that is this on heating gives twice HgO, that is mercuric oxide plus twice SO2, sulfur dioxide, and the process is roasting or calcination. Yes, student? Process is roasting or calcination.
Roasting.
Okay. So process is roasting. Process is called what? Roasting. Is there any doubt? Similarly, mercuric oxide form on heating gets converted to Hg plus oxygen. Hg plus oxygen. The next step is refining of metal. Refining of metals. Already I told at the beginning itself what is refining. Process of removal of impurities. That is called what? Refining. Removal of impurities. Impurities. That is known as what? Refining. Refining can be done using electrolysis. Electrolysis. Now, what is electrolysis? Electro means electrical energy. Lysis means breaking. So electrical energy is used to break chemical bond, or an electrical energy is converted into chemical energy. What is electrolysis? Electrolysis is a process in which electrical energy is converted into chemical energy. Electrical energy is converted into chemical energy. Of course, electrolysis is carried out using two electrodes. One is called cathode and second one is called anode. Cathode is an electrode where reduction takes place. What takes place? Reduction takes place. Anode is an electrode where oxidation takes place. Oxidation takes place, right? So cathode is an electrode where reduction takes place. Anode is an electrode where oxidation takes place. Okay, एक दो minute. Oxidation takes place, right? So both reduction and oxidation is essential. By oxidation, one can remove impurities. By reduction, one can get a pure metal. One can get a pure metal, and thus a refining can be achieved. And this is the end of second topic, that is metals and non-metals. Okay, we'll stop here. Thanks a lot.
Recording.
Huh?